Today we are going to continue our discussion on the types of element in the network. So we have already completed resistors and the inductance, right? So this is the third lecture with the types of elements in the network. So I think resistance and inductance are good much thought, and you guys may not have any doubt, I think. So even if you guys have any doubt, please post in the comment section. I will be there to rectify that. So today let's take what do we mean by capacitor. So two connecting plates separated by the dielectric material is called capacitor. So think how it will be look like is that, so there will be the dielectric charge that will be present, dielectric material that will be presented between the two plates. So this is how the capacitance effect will come into picture. So if you guys see, this is the two connecting plates. So this will be the conductors, and which will be separated by some dielectric material. The dielectric material may be even air or even some material that may be given over it. So we guys will be applying some potential. So the potential that we will apply, so it will be positive and negative will be applied there. So because of this, there will be the net electric field that will be produced in this direction. So because of that, the positive charges will be aligned in this and the negative charges will be aligned in the opposite plates. So this is how the charge that is be stored in the capacitor. So the connecting plate in the capacitor remain charged on their surface. So the induced charges are produced. Induced charges are even dipoles that will be produced between the connecting plates. So that is how the charges will be get stored over the plates. So the capacity of storing charge is given by the property of capacitance. So the capacity to store the charge. So the capacity of charge storing. So capacity of storing the charge is given by capacity of storing charges. So this can be stated as the capacitance. So everywhere the property or amount that which the physical property or quantity is measured will be stated with the prefix that is tons. Okay, so the charge on the plate Q, which will be directly proportional to the potential difference across the plate. So the charge on the plate. So the charge on the plate, which will be stated as Q, so which will be directly proportional to the potential difference across the plates. Okay, so this is what the quiet thing. So there is some generalized formulas also that Q can be varied as a CV. So capacitance and the voltage. So C is the proportionality constant that is called capacitance, and SI unit is the farad. So SI unit will be farad. For inductance that will be Henry. Okay, so if V is equal to 1, then we can clearly state the charge stored will be directly proportional to the capacitance. The capacitor with the higher capacitance stores more charges. So that is for the general thing. So C can also be stated as the epsilon A divided by D. So this is with the plate. So epsilon is the permittivity of the dielectric medium. So epsilon can be generally stated as epsilon naught equal to epsilon r. So that will be epsilon r naught is the relative medium. So if there is any medium is filled, based upon that constant, it will vary. So A is the cross-section area of the plate and D is the distance between the plate. So this is what the formulas that will come into picture. So I hope capacitor and capacitance effect will be fine with this. So let us now calculate power and energy for the capacitor. Power and energy. So as we discussed the same thing, so like how we done for the resistance and inductance, the same rules apply here. So we know that I, which is equal to dq by dt. So this is a generalized current flow charges. So which is similar to C dV by dt. So I in the capacitors can also be written in the same way because Q is equal to CV. Okay, so that's what we are doing. So the instantaneous power P of t, which is nothing but V of t into I of t. Okay, so if we apply I of t, then that will be C dV by dt. So this is CV of t dV by dt. So that is what the thing. So dV of t over the dt, because this is instantaneous. So if we calculate the energy stored over the element, that will be nothing but the integration of P of t over dt. So that is what the formula to calculate the thing. So U of t can also be written as the integration. So integration of C dV by dt. The integration charge will come into picture. So this V of t. So dI by dt, that will be getting cancelled. So this is dV of t. So which will be equal to of C over dV of t the whole square. Okay, so this is what the formula. It is nothing but the charge stored in the or energy stored in the capacitance. So this is how. So if there is asked energy stored between the two time, so this will be applicable for all the three elements. So charge stored between T1 and T2. So if there is asking like this one, particular duration, what will be the charge stored, then the net variation of the electric charge stored will be U of T2 minus U of T1. So just we need to substitute the time value and we can calculate. Even this formula will also be applicable. So 1 by half V square T2 minus V of T1 square to that of thing. So this is how the things will change when we are considering over the duration. So why capacitor does not allow sudden change of voltage? So this is one very important thing, guys. So here, why capacitance does not allow sudden change of voltage? Why capacitor does not allow doesn't allow sudden change of voltage? So if you guys know the answer, please post in the comment section. So change of voltage. So this is very simple, guys. So plenty of engineers may lag in this concept. So this is even more even this is not an interview question, but in many of the practical labs they may ask this question. In your college labs they will ask question. So one of the IIT entrance also they ask this question. I think in, one of my friend have informed me. So once he is cleared the MTech, once he cleared the gate examination and he was trying to attend the interview at the IIT Madras. I think IIT Madras or IISc, I'm not sure. So where they ask this question. So why there is no sudden change of voltage, that will not happen, the capacitors won't allow. So why the current will be zero, or that will be as it is the same of the previous case, like that way they asked. So practically capacitance does not allow the sudden change of charge stored in the capacitance. So the thing is that what the practicality is that, so practically capacitor doesn't allow sudden change of charges, because we know that the voltage and charge is directly proportional, right? So that is why we are taking that. So we know I, which is equal to dq by dt. So if it is sudden in the case, what we can state is that the sudden can be resemble dt is equal to 0. So if dt is equal to 0, I need to be infinity. Okay. So but this is not possible, right? So I cannot go infinity as of sudden. So that is why we are stating with this formula, we can state that the sudden change of the so not sudden change, the I can't be infinity. That will be some defined quantity only. So that is why this is not possible. So but Q is equal to CV. We know this formula. So we say the capacitor does not allow sudden change of voltage across it. The voltage across capacitor may change sudden in some cases, but the charges cannot. The voltage can be changed of sudden, but the charges won't change. So charges won't change. So charges won't change of sudden. Of sudden. Okay. So that is one important thing, guys. So whenever there is a sudden change in things happening, that will not allow to happen in the capacitors. So that is what the thing that we need to take into account. So the plates connected together can transfer charges to each other, but the charges of these plates cannot flow elsewhere. So thing is that between the two plates that it can exchange any kind of things, just but that charge cannot go anywhere. So means there will be some conservation potential will also happen. So principle of charge conservation is that charge can either be created or be destroyed. So the applied charge conservation to the plate of capacitors connected to each other. So that thing will help to solve some of the few problems there. So from here we have completed all our understanding over the capacitor, inductor and the resistor. So this is very important, guys. So why I am stating again and again is that RLC. So these three components which will be repeating everywhere. So even in transients, even in steady state analysis, even in two port, what are the things that you may study? This is very important, guys. So you guys can't skip or can't ignore these three elements. So we should not study as a namesake. So we should know each and every term behind it. So what do you mean by resistance? What is inductance and what is capacitance? What will be the power energy stored? What will be the I, V, C, I, V, P of T, C of T, U of T? Everything we need to for all the elements. That is not only formula based. That is also with the world vast thing. So why the charge store happen? How the charge stores happen? Everything we need to understand it. What do you mean by flux linkage? What do you mean by capacitor, charge store, discharge? So these things. So we have see some introduction. This is not a full part. So in the next class I will be solving few problems over all the three elements. So that will be very much understood for you guys. So then after that we will be going into the actual core thing. So also we need to discuss few things like power source and electric things that we already discussed, but I will explain little more on that. So there also we have some idea there. After that we will be solving the Kirchhoff laws, so like KCL, KVL, those things I will be starting from next lecture, so that we can get into the network topic ASCP. So stay tuned guys. So like, share and subscribe channel, so motivate me to post more videos like this, so that I will be posting these kind of videos continuously. You guys can also learn more things on this. So please follow and share to your friends. So please like, share and subscribe channel. Thank you guys. Stay tuned.